Hi everyone, my name is Daniel Glogowski. I'm a product manager working at NVIDIA in the Enterprise Product Group. My focus is really on NVIDIA AI Data Platform, which I'm going to talk about today, but also on NVIDIA AI Blueprints. And I'm very proud to be here today talking about our partnership with DDN on the DDN HyperPOD and the NVIDIA AI Data Platform. And today I'm going to talk about how you can unlock business value from your data with NVIDIA AI Data Platform and DDN HyperPOD. I'm going to start with AI factories and how they relate to AI Data Platform. So we're seeing two major trends in computing kind of driving the pivot to AI factories. One, with the rise of AI, we're seeing a shift in enterprise workloads from CPU to GPU. And also, we're also seeing a shift in just the compute demand, right? Like Jensen keeps talking about the three scaling laws. We start from the pre-training, which means that the more data you throw at training, the smarter the AI gets. Post-training with RLHF and instruct fine-tuning, and also with test-time compute. Models that are now reasoning, producing more and more tokens to reason through hard problems, increasing the compute demands over time. So with those two trends in computing demands are call for a purpose-built infrastructure with GPU acceleration at the core, or AI factory. So an AI factory is a full stack platform that pretty much takes in electricity and data, and it outputs tokens or intelligence. At NVIDIA, we work with our ecosystem partners to build this end-to-end platform for building, deploying, governing, observing these AI applications, scaling them, and those span across four layers. The software layer with the NVIDIA AI Enterprise, with our NIMS/NeMo inference microservices, NVIDIA Blueprints, GPU orchestration, AI workload GPU orchestration with GPU operator, and etc. Right? Also on the compute side, we have the CPU with the Vera and GPU with the Blackwell, the networking. And we also work with our partners like in DDN and Supermicro and other partners to supplement this full stack and create this big compute power, right? But with all this compute power, you don't want the GPUs to sit idle. So in order for and they will sit idle, right? They will sit idle unless you feed them with AI-ready data. AI-ready data that is not only secure but governed. And that's why every AI factory needs an AI data platform. Okay, the AI data platform here you're seeing it's not only storage. Okay, so this is GPU accelerated storage that is sitting in your storage and it's processing. It's making your data AI ready for those downstream applications, and it's doing it in place in the storage. Now the job to be done for an NVIDIA AI data platform is to make the hard problem of AI data preparation easy for the enterprises. Okay, we're taking the GPU and we're putting it closer to the storage. We're closer to the storage, and those are GPUs that are dedicated for the job of processing your data in place and making it ready for those downstream applications as a background operation. Okay, so that's a background operation. Now, when you have the GPU closer to the storage, you're actually getting a few things. One, you don't have to copy your data over to an AI factory where the inference is done. You don't have to copy it back, right? So that's not only inefficient, that's also insecure. Why is it insecure? Because let's say you have your PII data in your storage, you have to process it. You don't want to send it over to the AI factory for your inference, where the data is exposed up to the data plane, right? You can process the PII, you can redact the PII in the storage where it sits. Also, you have your B200 GPUs in the factory. You don't have to, they're powering your chatbots or your agentic AI. You don't have to use them. You can let them do what they do best, which is powering those applications. And thirdly, and probably most importantly, with the AI data platform, your AI data platform scales as a function of your data, versus the AI factory, which scales as a function of your number of queries and your number of users. So you can scale your AI data platform and your AI factory separately, independently, and you can right size those GPUs to the right workload. So you need more data, you throw more GPUs at the data. You need more queries and users, you throw more GPUs at that. So how is it happening today? So you probably have a central data lake where all your data lives. And then you have a set of like data science teams that are pretty much, running their own pipelines, creating their own vector databases, creating their own local copies of the data. And that immediately creates this problem of governance and security, because now you have, all these, not only the data is now not in sync with your source data, but also the metadata and the access controls. Those are all been now drifted away from the source data. So you get like data inconsistencies, you get a data sprawl and data silos. You now also have rising costs because you're copying the data multiple times over. You have compute surge, and also just operational cost of maintaining all these copies and all these pipelines. So that creates a increased time to value, right? And you're also pretty much blocking yourself from getting into production. So with the AI Data Platform and with DDN HyperPOD, you're getting Easy Button, a turnkey platform that is full stack. Okay? You're getting the software, all the hardware, and it does the job of, again, continuously processing and making your data ready for AI. So all of your data is AI ready. You get it in near real time as well. So let's take a look at like a quick logical representation of an AI data platform from the lens of a RAG pipeline. Okay. So on the right here, we're going to go through right to left and top to bottom. On the right here, you have your enterprise documents. Those can be multimodal documents with charts and tables and images. Those are multimodal documents that are getting synced into, let's say, Infineon, right? They're getting synced into Infineon. As they're getting synced, they're running through a data pipeline, a RAG pipeline that extracts, the different artifacts from the documents. It then embeds them, and it then also indexes them in a GPU accelerated way with the NVIDIA QBS here through the GPU. And it all goes into a centralized repository which is again governed and secured. It has all the right access controls. You're no longer having to deal with drifted access controls and these security risks. And you're exposing all of that to your factory, to the downstream inference through a semantic search or a keyword search API. Okay, so there you have a reasoning model and your agentic application. And the AI data platform is feeding all that in a continuous fashion. Now I talked about the RAG pipeline, but this is extensible to pretty much any data modality. Think about batch or streaming. A use case that we're going to talk about in a minute is, for example, video search and summarization with video, archival video, and streaming video. And it can be replaced really with any GPU accelerated pipeline that takes in data and prepares it for that downstream application. So I said that I also work on NVIDIA AI blueprints. These are NVIDIA AI blueprints. Those are reference architecture that are implementing code. You have multiple here, but there's a larger set from this. But these are like 5 use cases that we've seen AI data platform being successful in the field. So one is multimodal agentic RAG, which I just talked about, continuously ingesting and indexing your PDFs, your graphics, your audio into semantic search. Video search and summarization, so ingesting massive volumes of archival data or videos and audio and images, both in streaming and archival mode. For search summarization and QA, think about factories or smart cities, etc. A deep research agent, which is our opinionated IQ blueprint for deep research with your enterprise documents. But we're also seeing a lot of success with data curation at scale. So the demo that we're going to see here in a minute, if you haven't seen it, I highly recommend seeing it. It uses Nemo Curator. It's a pipeline for deduplicating your data and for curating your data for downstream inference and training and fine-tuning. I'm going to talk about that demo in a second. But the last one here is the centralized cache for distributed inference. So distributed inference requires KV cache offloading into the storage. So offloading your inference cache for high-speed storage in a scalable latency for agentic communication. So just starting to wrap up here, we're seeing, storage evolving over time, right? Like we're seeing the storage controller evolution over time, putting more and more compute in it. Started from enterprise data organization orchestration with file system management, RAID, storage network protocols, moving up to deduplication, encryption, keyword search, etc. And now with the GPU in the storage, you're actually unlocking new capabilities that the storage can help. Talked about preparing your data for AI with the continuous ingestion, but also think about agents that are working in place in the storage for things like data cleansing, masking, classification, right, redaction, advanced interpretation, sentiment analysis, classification, etc. Those are agents that are working in your storage, leveraging the GPU. And lastly, as I mentioned before, For large-scale distributed inferencing, the KV cache offload, those are also now unlocked with our networking and networking solution. So to summarize, with the DDN Enterprise HyperPOD, you get an easy button. You get a turnkey solution that is fully integrated and optimized. It's full stack. It's hardware and software all working in tandem to provide you an optimized AI inference, RAG, and real-time data processing solution. It's secured and governed. It's centralized, it's secure and governed. It's enterprise-grade security with end-to-end encryption, with all your role-based access controls and audit logging across the AI data pipeline. And lastly, it's scalable, right? Like I mentioned before, you have flexible modular architecture that allows you to independently scale your AI data platform and your AI factory based on your needs.